Okay, up until now we've talked about kind of really, actually we've talked really specifically about features of linear, well, features of quadratic functions. We've actually learned quite a bit of information, but still, we got the simplest way to figure it out by eyeballing it and by looking at the equation. So we need to make sure that we understand the difference between linear, quadratic, and other. Okay, so this guy right here is my linear function. Let me take these papers out from under here. This guy right here is my linear function, okay? I know that he's my linear function because he makes a straight line, okay? I can tell that he's a linear function. He makes a straight line. This guy over here is my quadratic because his graph is one of Ebola. Just kidding. It's a parabola. Okay, that's how I can tell. This is distinctive. I've had kids ask me, so it's either going to point up or it's going to point down. It's not going to point side to side. This is distinctly a quadratic formula. It's got, because it has a parabola. Okay, this guy over here is neither. It's actually a cubic function, but you'll learn about that. I'm not sure when. I think algebra 2, but I could be wrong. Okay, it's neither because what is that? It's nothing we've seen before, okay, but I will tell you right now it's a cubic function, okay? So that's how we can tell from looking at a graph. I mean, it's kind of obvious, but you know, it's worth repeating. I mean, this one has almost kind of a parabola shape. It's almost like the parabola like got all twisted up and freaked out, okay? So quadratic is a parabola, linear is a straight line, and if it doesn't look like one of these two, it's neither, okay? The next thing that we want to look at is equations. Okay, so when I look at an equation, this one right here is my linear function. And I've talked about this a lot. I've talked about how every x has all these invisible things around it. Okay, so every x has like it's over an invisible 1. Okay, it's got an invisible 1 exponent. It's got an invisible 1 coefficient. Okay, the 1 exponent is the thing that we're most interested in here because a linear function has either no exponent, but no exponent means the highest exponent is the first power. So the highest order exponent, and that's what we mean. When we say highest order exponent, we mean the high. So like here, if I look, what is the highest exponent you see? It's this 3 here, okay? For this one, the highest one I see is this 2 here. And for this one, since I don't see anything, I can draw in my invisible 1. For this one, the highest order exponent is 1. Okay? What do you think my quadratic's going to be? I mean, I have to the second power. I've got, you know, our parent function is x squared, right? So this one that has x squared as the highest order exponent is my quadratic. Now, this one has a squared variable, but it's not the highest. It's not the biggest exponent. My highest order exponent has to be 2. Okay, so this is my quadratic. Highest order exponent is 2. And this guy over here is neither. Again, it's cubic. Its highest order exponent. I mean, technically, it's higher order exponent. What we care about is that it's not 2 and it's not 1. But 3 is not 2 or 1, so we can write that down. Okay, so when I look to see if something is linear or quadratic, linear means it's either got no exponent or it's got an invisible exponent. I had a lot of people today say, well, that one's linear because it's in slope-intercept form. But remember, we have other forms of linear equations. We've got standard form, ax plus by equals c. So we've got point-slope form. Okay, sorry, y minus y1 equals mx minus x1. So we've got other forms of linear equations that don't look like this. So just because it's in slope-intercept form, it happens to be linear, but that's not the only form we have, so that can't be our criteria. The criteria is that the highest exponent I see is 1. And for my quadratics, the highest exponent I see can be 2. Anything higher than 2 or 1 or lower than 1 isn't going to work for me, and we'll talk about lower than 1 later. Okay? Now, the last thing we're going to talk about, and this is what you guys would have had in your notes at this point. The last thing we're going to talk about is figuring out what type of function we have from a table. Okay, now this is where it gets a little weird. Okay, it's not bad. It's just a little unusual because it's something that you've never done before. So don't freak out. Okay, you're freaking out. Don't freak out. I said don't freak out. Okay, so when we look at this, okay, the way that I tell if something is linear is it has a constant rate of change. Okay, has a constant rate of change. Okay, so that means my delta y over delta x, my delta y over delta x is going to be constant for every row in the table. Okay, so let's see if we have a constant rate of change here. Okay, we're going up +1, +1, +1, +1. Over here I'm going up +4, +4, +4, +4. I can tell already without even actually writing out delta y over delta x, which is 4 over 1 for every row. I can tell 4 over 1, 4 over 1, 4 over 1. I've got the same rate of change. This has a constant rate of change. That makes it linear. Oh, time for the buses. Okay, great. So this one down here is quadratic. We're not going to do one that's neither because why, right? Okay, this one is quadratic. And what makes it quadratic, I'm going to show you here in a minute. It's a little weird. I might actually erase and do it again. Okay, so I'm keeping my eraser on standby. All right, so I'm going to look at my delta x, my delta y, my delta x, okay? This is +1 all the way. When everything is +1, I'm not so concerned about it. I don't really care about x at this point because it doesn't matter what I put over 1, it's going to be itself. So the fact that I have the same change in x tells me that my change in y is what I need to look for. So now when I look at my change in y, this is +7, +11, +15, +19. Okay, so this is obviously not linear because 7 over 1 is not the same thing as 11 over 1 or 15 over 1 or 19 over 1. Okay, so this is the first difference. And when we talk about finite differences, we're talking about the difference in y in this case. Okay, so the first difference in y, I'm going to put a little 1 here. Not that I need to, but this is my first difference. Okay, now I'm going to just see what happens when I go out a second time. Okay, 7 plus 4 is 11, plus 4 is 15, plus 4 is 19. My second difference is constant throughout the table. That's how I know that I have a quadratic function. Now, I have had students say, well, if I go +4 plus 0 is 4 plus 0 plus 0, once I find a common difference, I don't keep going. I stop. Once they're all the same, I stop. Okay? So here, I stopped because I stopped at my first difference. Oh, hey, linear has an exponent of 1 and a first difference. Okay, quadratic, I have a second difference is constant. Oh, and hey, quadratics have a squared variable. What? What? Is that a pattern? Oh my gosh, it totally is. Yeah, it totally is. Okay? So, again, linear has a constant rate of change, which means my delta y over delta x is the same for every row. Quadratic also has kind of a similar constant, but it's not the first delta y, it's the second delta y. Okay? So it's not the first difference in y, it's the second difference in y that has to be the same for it to be quadratic. And once if the first difference is all the same, I stop. So it's not like it can't be both, it's one or the other. Okay? So let's try these other 3 examples and see if we can figure out what they are. Okay, so this one is going up by 1, and this one is going down by 1. That's a minus, by the way. Okay, well, -1 over +1 is going to be linear. I have a constant rate of change there. Okay, let's take a look at this one. 4, we have +1, +1, +1, +1, +3, +5, +7, +9. So my first difference is a no-go. Let's try my second difference. this one is quadratic. So on this one, my first difference was the same. On this one, my second difference is the same. Somebody is really trying to get in touch with me, but it's okay. Okay, so now let's look at this one. I mean, it's not going to be right, okay, but, okay, plus 4, plus 16. Oh my gosh, what is that? Plus, is that 34? Okay, I'm sorry, I'm going to have to use my calculator. Plus, it doesn't matter. Okay, well, whatever. Yeah, I'm going to use my calculator. Okay, so 112 minus 54, 58. Okay, 54. Okay, all right, so now let's try. So that was my first difference. Here is my second difference. Okay, this is 12. 34 minus 16. This is 18. 58 minus 34. This is 24. Just for the heck of it, you know what my third difference is? Oh, hey! Oh, hey, look at that. This one is cubic. It's to the third power. It matches this one over here. So every exponent I have, okay, you know what? I don't care about that. But you see the pattern. It's there. It's out there. But don't let that confuse you. We only care about these two. We're not going to try and figure out if something is cubic or whatever comes after that. Okay, we're only going to worry about quadratic and linear. Tomorrow we're going to talk about finding domain and range, and we're going to kind of start transformations. So, you know, we'll have more about that tomorrow.